Okay, so this is the second part of the 7 principles of trig. We talked about last time 3, basically 2 triangles, and then we introduced the graphs that you might need to see. So now that we have the sine graph, we have the cosine graph, which is very similar to the sine graph. It's just a bit shifted compared to the sine graph. So we have the same values. We're going to keep pi over 2, pi, 3 pi over 2, 2 pi. Right? So now the difference, and it can be hard to memorize at first, but with practice and keep drawing it, you'll get it. So with the sine graph, same values, 1, -1, 0, right? So you start with the sine graph high, middle, low, middle, high. So from these ranges of values, it's just pretty much like that. Kind of like a parabola that kind of opens up towards the ends. And actually you can kind of see that with the sine graph. It's just shifted over. Because if I continued this over, it would just be like this, which kind of does the sine function like that again. So yeah, that's another cosine. So they ask you the cos of that angle. You have it right here. So the cos of 3 pi over 2 is 0. Just draw that on any question. They give you that. And the cos of 3 pi over 2, if they ask you that in degrees, you just use the conversion like I said, 180 over pi. And then you can make this to 90, so you get 270 degrees as that. Another principle of trig is when things are positive. So how I like to make it's called ASTC. Now I know maybe you all haven't taken calculus yet, but a way to remember this type of graph is ASTC, or all students take calculus. That's how I remembered it. I think it's a great way to remember it. So the A stands for that all are positives. So in this area, this is like 0 to 90 degrees. When you're dealing with those type of angles, the sine value from 0 to 90 is positive, the cos value is positive, and the tangent value are positive. So these values represent which is positive. So if I go here, the sine value is positive because the sine value represents the y, and the cosine value here represents the x. So cos is x, sine is y. So because the cosine based on the x is negative here, this makes the cosine negative, but the sine positive because positive y, right? So now tangent is positive here because it's a double negative. When you're dividing a negative by a negative, it becomes a positive. So negative cosine value, negative sine value, right? Which actually leads us to, well actually, and then the cosine here is positive because it's the only one that's positive, as the sine here is negative. As sine is based on the y-axis, cosine is based on the x-axis in this scenario. Now, I alluded to how tangent here is positive because the y and the x are positive, right? But why was I doing sine divided by cosine? Why was I doing the y here divided by x? Well, actually, it brings us to our another principle, that tangent of an angle, we'll say x, is equal to the sine of that angle divided by the cosine of that angle. So if the sine and the cosine are both negative, that means the tangent is positive. So being in this section, the only value that's positive is the tangent. So that's the main things to know from that type of graph. So actually, I know this could be a little complicated, but actually what I alluded to earlier, the last key to trig that will always come in handy for all trig problems is SOHCAHTOA. I went into that earlier, but just always think of that, and that really sets it up. Thank you for watching. This is part 2 of trig. Any help with quizzes and tests?